We already learned graph transformations. Now let's look at how these transformations apply to trigonometric graphs. Y equals a sin x is a stretch of y equals x in the y direction with factor a. This is the graph of sin x. We use radian for x here. So one period is 2 pi. The max is 1 and the min is -1. This is the graph of 3 times sin x. We can see it's stretched along y with a factor of 3. The max is 3 and the min is -3. This is the graph of 1/3 times sin x. We can see it's stretched along y with a factor of 1/3. The max is 1/3 and the min is -1/3. Given a graph, we can find a. It is equal to max minus min over 2. Y equals minus sin x is a reflection of y equals sin x in the x-axis. These are their graphs. Let's look at the origin in the graph. In y equals minus sin x, instead of going up from 0 to 1 at first, it goes down from 0 to -1. Y equals sin bx is y equals sin x stretched along the x direction with a factor 1 over b. This is the graph of y equals sin x. This is the graph of y equals sin 2x. It is stretched in the x direction with a factor of half. The period becomes pi. In general, the period of sin bx becomes 2 pi or 360 degrees over b. Here b is 2, so the period becomes 2 pi over 2, which is pi. If you are given a graph, you can find the period from the graph. And then find b, as 2 pi over the period. Now let's put sin x and sin 2x together. This is graph of sin half x. The period is 2 pi over half, which is 4 pi. Now let's put sin x and sin half x together. Y equals sin x plus c is a translation of y equals sin x by vector minus c, 0. This is y equals sin x. This is y equals sin x plus third pi. It's moved to the left by third pi. Now let's put them together. This is y equals sin x minus third pi. It's moved to the right by third pi. Now let's put them together. Y equals sin x plus d is a translation of y equals sin x by vector 0, d. These are the graphs of sin x plus 1, and sin x minus 1. When it's plus 1, the graph moves up by 1. When it's minus 1, the graph moves down by 1. Now let's put together all transformations. Sketch the graph of minus 2 sin x plus pi over 2 plus 1. Let's do the transformations from inside out. First, let's transform y equals sin x to y equals sin x plus pi over 2. This is y equals sin x moved to the left by half pi. Then, multiply it by 2. This is a stretch in y with factor 2. Then, multiply it by minus 1. This is a reflection in the x-axis. Finally, add 1. This is moving up by 1. In the final graph, we can see that the period is 2 pi. Since sin is between minus 1 and 1, minus 2 sin is between minus 2 and 2. And minus 2 sin plus 1 is between minus 1 and 3. So the max is 3. The min is minus 1. Given a graph, we should be able to find the equation. Here's a sine graph. The max is 1 and the min is minus 3. So a is max minus min over 2, which is 2. The center is y equals minus 1. Let's draw the center line. We can see that the graph is not reflected. So there's no negative sign. The center line is moved down by 1 from the x-axis. So d is minus 1. The period is pi. So b is 2 pi over period, which is 2. Therefore, the equation is y equals 2 sine 2x minus 1. Cosine transformations are very similar to sine, only that the graph of the base period looks different. This is the graph of cosine x. In the base period of 0 to 2 pi, the y value goes down from 1 to 0 and minus 1, and then goes up to 0 and 1. This is 2 cosine x. It's stretched along the y direction with factor 2. Min and max become minus 2 and 2. This is half cosine x. It's stretched along the y direction with factor half. Min and max become minus half and half. So a is also max minus min over 2. This is minus cosine x. It's a reflection of cosine x in the x-axis. This is cosine x plus quarter pi. It's moved to the left by quarter pi. This is cosine x minus quarter pi. It's moved to the right by quarter pi. This is cosine 2x. It's stretched in the x-axis with factor half. The period becomes pi. This is cosine half x. It's stretched in the x-axis with factor 2. The period becomes 4 pi. So the period is 2 pi over b. And b is 2 pi over period. This is cosine x plus 2. It's moved up by 2. This is cosine x minus 2. It's moved down by 2. You should be able to sketch a graph with these transformations, and get the equation from a graph. This is tangent x. The base period is from minus half pi to plus half pi. The function values go from negative infinity to positive infinity in a period. If it moves down by 5, it becomes tangent x minus 5. If it moves up by 5, it becomes tangent x plus 5. If it moves left by quarter pi, it becomes tangent x plus quarter pi. If it moves right by quarter pi, it becomes tangent x minus quarter pi. Same as sine and cosine, b changes the period of tangent. This is tangent 2x. The original period is pi. One period is from minus half pi to plus half pi. The new period becomes pi over 2, which is half pi. One period is from minus quarter pi to plus quarter pi. This is tangent half x. The new period is pi over half, which is 2 pi. One period is from minus pi to plus pi. This is minus tangent x. It's a reflection in the x-axis. In this class, we learned y equals a sine x, y equals a cosine x, y equals a tangent x, are a stretch in the y direction with factor a. For y equals a sine x, y equals a cosine x, a is max minus min over 2. Y equals minus sine x, y equals minus cosine x, y equals minus tangent x, are a reflection in the x-axis. Y equals sine bx, y equals cosine bx, y equals tangent bx, are a stretch in the x direction with factor 1 over b. For y equals sine bx, y equals cosine bx, period is 2 pi over b, b is 2 pi over period. For y equals tangent bx, period is pi over b, b is pi over period. Y equals sine x plus c, y equals cosine x plus c, y equals tangent x plus c, are a translation in the x-axis by minus c. Y equals sine x plus d, y equals cosine x plus d, y equals tangent x plus d, are a translation in the y-axis by d.